Hello everyone. On this video we will take a look at cylinders and spheres. Okay, so first, before we do that, we're going to kind of go back in time and look at the circle, because the circle is actually just closely related to a sphere and a cylinder. Okay, so if you remember, the circumference of a circle is the distance around the circle. So if you start at one point and you go around the surface of the circle and go back to that original point, that's the circumference. Okay, so to calculate the circumference, the circumference is equal pi times the diameter, or the circumference is equal to 2 pi times the diameter, times the radius rather, depending on which unit of measure you have. If you have the diameter, you use this formula. If you have the radius, you use this one. Okay, now the diameter of a circle is just the distance across the circle through the center. So if you go from this end through this end, and you go through the center, which is right here, then that distance is your diameter. But if you go from the center to any point on the surface of the circle, then that is your radius. Okay, and the diameter is 2 times the radius, and the radius is 1/2 the diameter. All right, so if you are still writing this, feel free to press pause, but we're going to go ahead and move on to the next page. If I can separate these, there we go. Now, a cylinder is a solid object with two identical circular bases. Okay, so it's a little different from, well, could be a little different from a right cylinder, which has curved walls that are perpendicular to the bases. So the right cylinder, the lateral surface area, which are the sides, and the bases are perpendicular, which means there's a 90-degree angle. Okay, now just for a regular cylinder, think about like an enclosed child slide, where it goes like this. You have an opening at the bottom, you have an opening at the top, okay, and a kid just slides right through it. This is a cylinder, but it's not a right cylinder, because the bases aren't over each other, and the angle between the base and the side is not 90 degrees. Okay, so we're going to be dealing with just the right cylinder. You see my little cutout photo of it here. Okay, so let's go ahead and go up a little bit. Okay, so what if we let D equal the diameter of the base? What if we let R equals the radius of the base? And we let H equals the altitude of the cylinder, which is just the distance between the bases. And remember, we call it altitude instead of height, because if you get this cylinder and you turn it on its side, you don't want to make the mistake of thinking the height is just going up and down. So that's why we say H is the altitude, which is the distance between the cylinders. So no matter how you turn this, you still get the same value of H for your altitude. And you don't mistakenly say it's the height when it's sideways. Okay, so to find the lateral surface area, it all depends on what values are given to you. So if you're given the circumference, the lateral surface area is going to equal the circumference times the altitude. Remember, that's when you're given the circumference. Now, if they just give you the radius and the altitude, the lateral surface area will equal 2 pi times the radius times the altitude. And if they give you the diameter, then you use the formula, the lateral surface area is equal to pi times the diameter times the altitude. Okay, so it depends on what's given to you. Okay, so let's go ahead and move this up a little bit. Now, to find the volume, once again, it depends on if they give you the radius or the diameter. Okay, so if you know the radius, then your volume is going to equal pi times the radius squared times the height. Okay, remember that's when you know your radius. If you know your diameter, then the volume is going to equal 1/4 times pi times the diameter squared times the altitude. Okay, so if you get 1/4 divided by pi, if you combine these two, you get approximately 0.7854. So either one of these formulas will be okay to use. It all depends on if you want to use 1/4 times pi, or if you want to just combine those and get this decimal number here. But both of those will be multiplied by the diameter squared times the altitude. Okay. Now to find the total surface area, that means you're going to find the surface area of the sides plus the surface areas of the two bases. Okay. So to find if you know the radius, then your total surface area will be 2 pi r times r plus h, or your radius times your altitude. But if you know the diameter, then your total surface area will be pi times your diameter, and you're going to multiply that by the diameter divided by 2 plus your altitude. All right. So if you're still writing this, of course, feel free to pause it and finish up. But we're going to go ahead and move on. Let's separate these to our first example. All right. So let's say, move that down. There we go. We want to find the lateral surface area and volume for the following cylinder, and we want to round to the nearest whole number. Okay, so using the formulas on the previous page, I want you to go ahead and press pause and try to find this on your own. All right, so I'm assuming you've paused it and you've gone ahead and solved this one. So let's go ahead and verify your answer. Okay, so we know that in this case, for your base, you're going from one side to the other. So we know that our diameter is equal to 9. Now, if your base was from the center to the end, then that would be your radius. But since we're going from one side of the base to the other, and we know that width, so we know that our diameter is going to equal 9 inches, since the 2 slashes is inches in this case. Okay, and we know that the altitude, the distance between the two bases, is 20 inches. So our h is equal to 20 inches. Okay, so now we go ahead and calculate our lateral surface area. Okay, and that's the formula, since we know the diameter, L equal to pi times the diameter times the altitude. Okay, now if we were given the radius, then we'd use the radius formula. But since we have the diameter, we're going to use the diameter formula. Okay, so that's going to equal pi times the diameter. So we'll say pi times the diameter, which is 9 inches, times the height, which is 20 inches. Okay, so if we get 9 times 20 times pi, you plug that into your calculator, you get about 565.4866, and it keeps on going square inches. But since we want it rounded to the nearest whole number, that's going to be about 565 square inches for your rounded answer. Okay, now let's look at the volume. Okay, for the volume, remember you're going to use the volume is equal to 1/4 pi times the diameter squared times the altitude, or the volume is approximately equal to 0.7854 times the diameter squared times the altitude. So what I'm going to do is I'm going to go ahead and do both, so you can see that you'll end up with approximately the same answer. Okay, it'll be off by a couple of decimal points. Okay, so if we use this formula, we have 1/4 times pi times our diameter squared, which is 9 inches squared, times our altitude, which is 20. Uh-oh, got my unit of measure. 20 inches. Okay, so that's going to equal 1/4 times pi times 9 squared, so that's 9 times 9, which is 81. So that's 81 square inches times 20 inches. Okay, so if we go ahead and multiply those two, we end up with 1/4 times pi times 1,620 cubic inches. All right, so if we multiply pi times 1,620, we equal 1/4 times 5,089.38009, and it keeps on going, cubic inches. Okay, so we multiply those two now, we end up with 1,272.3450, and it keeps on going. Oh, cubic inch and not square. Okay, so this should be an approximate value. Since it's not exact, we kind of approximated there. But if we round it, we get 1,272 cubic inches for our rounded value. Okay, so if we use this formula, it's going to equal 0.7854 times our diameter squared, which is 9 inches squared, times our altitude. Okay, so this will be approximately, this is approximate to 0.7854. We multiply 9 inch times 9 inch times 20. Of course, we get 1,620 cubic inches. If we multiply those two together, we get approximately 1,272.348 cubic inches. We round that to the nearest whole number, 1,272 cubic inches. Okay, so as you see, the values are just a few decimals off. It depends on how exact and precise you wanted your answer. But if you're just rounding to like the nearest whole number or the nearest tenth, then using either one will be just fine. All right. So if you are still writing, feel free to press pause, but we're going to go ahead and move on to our next page, which goes over the sphere. Okay, so once again, it's going to start off with the circle. Okay, remember, a circle is just a two-dimensional surface where all the points are the same distance from the center. So if you start from the center, if you go to this point, or this point, or this point, or this point, the distance from that center to any point on that circle is all the same. Okay, and that's your radius. Okay. Now, once again, if you go through the center and go from one side of the circle to the other, at any 2 points going through the center, that will be your diameter. Okay. Now, the difference is a circle is a 2D surface where all of the points are the same distance from the center. A sphere is a three-dimensional surface where all the points are the same distance from the center. So think about comparing a ring where you know where the center is, and comparing a perfectly round ball. And right in the middle of that ball, you know that's your center. So if you go anywhere in any direction, up, down, left, right. So with a ring, you go up, down, left, right, and say on this paper, you will have your ring. But with a sphere, you can go up, down, left, right, go at a diagonal, and then come up off of the paper and go in any direction. Then go below the paper. So you're going in all dimensions. That's when you get your sphere. Okay, and the radius is really the same as in a circle because it's the distance from the center to any point on the sphere surface. Okay, same definition. It's just applying to a circle and a sphere. So of course you're going in more directions when you're dealing with a sphere. And you have the diameter of a sphere, which once again goes through the center and can go from one side to the other. Think of going from one side of a ball all the way through the center to the other, which lets you know basically how wide the entire thing is. And there's your image of a sphere. Remember, going from the center to any point on the sphere and going completely across. A lot of times you'll see the diameter shown like that. Same thing. It just shows the distance from one side to the other if you go through the center. Alright, so if you're writing, feel free to pause it and finish up. We're going to go ahead and move on to the next page. And what if we let r equal the radius of a sphere and d equal the diameter of a sphere? Okay. To find the surface area of that sphere, when you know the radius, it'll be 4 pi times the radius squared. If you know the diameter, then the surface area will be pi times the diameter squared. To find the volume of that sphere, it will be 4 pi times the radius to the third power over 3 if you know the radius. If you know the diameter, to find the volume, it will be pi times the diameter to the third power over 6. Alright. So if you are still writing, feel free to press pause. But we're going to go ahead and jump to our next example. Okay, so what if we wanted to find the surface area and volume in gallons of a spherical tank 8 feet in radius and round to the nearest whole unit? Okay, so we really don't need a picture for this because whenever you see spherical, you know they're talking about a sphere. Okay, and they gave you the radius, so we don't have to visualize it to be able to solve for it. All right, so what I want you to do is press pause and use the formulas from the previous page to try to solve this one. Alright, so I'm assuming you've gone ahead and pressed pause. So we're going to go ahead and verify your answer. Okay, so surface area. Okay, and we know our radius rather. Okay, so our surface area, you go 4 pi times the radius squared. So this is going to equal 4 pi times 8 feet squared. Okay, so that's going to be 4 pi times 64 square feet. So if we plug in 64 times 4 times pi, we get approximately 804.247719, and it keeps on going, square feet. When we round it to the nearest whole unit, this rounded gives us approximately 804 square feet when we round it. All right, so now let's look for the volume. Okay, now we know the radius, so we're going to use the volume is equal to 4 pi times the radius to the third over 3. Okay, so this is going to equal 4 pi times 8 feet to the third power over 3. Okay, so this is going to equal 4 pi, 8 times 8 times 8 is 512, so that's times 512 cubic feet divided by 3. So if we get 4 times pi times 512, we're going to end up with approximately 6,433.981754, and it keeps on going, divided by 3 cubic feet. Which, if you plug those into our calculator, we will end up with 2,144.66, and it keeps on going, cubic feet. But if we round it to the nearest whole number, 2,145 cubic feet. And remember, this is our rounded value. Okay, so now we have to get this, and we convert to gallons. All right, so if you remember, 7.48 gallons is equal to 1 cubic foot. Okay, so if we know that our volume is equal to, we won't go with the rounded value, we'll stick with this one to give us a more precise answer. 2,144 point, let's say 66, let's say 058 to give us a more precise answer. And it keeps on going, cubic feet over 1. We want to get rid of the cubic feet, so we have 7.48 gallons divided by 1 cubic foot, where the cubic feet, unit of measure, cancel each other out. So we multiply 2,144.66058 times 7.48. If we round it to the nearest whole number, should get 16,042 gallons as your rounded answer. All right. So if you are still writing, feel free to press pause, but we're going to go ahead and move on to our next example. Okay, so what if we wanted to find the surface area and volume of a sphere with a diameter of 22 feet and round to the nearest whole unit? Okay, so I want you to press pause because you know it's a sphere and you know the diameter. So go ahead and press pause and try this one on your own. Alright, so I'm assuming you've pressed pause and you've gone ahead and started on this one. So let's go ahead and verify. Okay, so we know the diameter is 22 feet. Okay, so surface area we're going to use the diameter surface area formula. There we go. All right, so we know that we're going to have pi times 22 feet squared. Well, it's going to equal that. We haven't put in the value of pi yet, so it's still equal. Okay, so that's going to equal pi times 484 square feet. Okay, because 22 times 22 is 484. Now, if we multiply that by pi, we end up with approximately 1,520.5308 square feet. But rounded to the nearest whole number, 1,521 square feet, if it is rounded. Okay, so now we look at the volume. Again, because we know the diameter, we use the diameter volume formula. This volume is equal to pi times the diameter cubed over 6. Okay, so that's going to equal pi times 22 feet cubed over 6, which is pi times 10,648 cubic feet over 6. You have 22 times 22 times 22. Okay, so if we get pi times 10,648 and divide that by 6, we get approximately 5,575.2797, and it keeps on going, cubic feet, which rounded is 5,575 cubic feet for our rounded answer. All right, so hopefully this made sense, and I'll see you on the next video.